Hello, so today we are going to do problems from weekly contest 389, this week's weekly contest. And the second problem is count substrings starting and ending with some character. So basically we have a string S and we have a character C, and we want the total number of substring that do start with C and end with C. So they start and end with the same letter. Now this can be just a single letter, right? For example, A starts with A and ends with A. So if we take a look at this first example, how many substrings start and end with A? Well, first of all, just the single letters, those start and end with A. But then, so those are 3. But then we have this one starts and end with A. So now we have 4. We have this one, the entire string, so we have now 5, and we have also this suffix here, so we have overall 6. Okay, so that's the idea. You can also take a look at this one, same thing, 3, that's single letters, and then we have this one, and the overall thing, so 6 overall. Now this problem is the string length can be 10 to the power of 5, but the letters are up to 26 because it's lowercase. So this tells you we can't really do a brute force open squared solution, right? But let's still look at a brute force and see what ideas we can get from a brute force solution. So we can't do it because it won't pass. But one thing to think about here is we care about the starting and end position, and it has to be like a valid substring. And for that, the starting position needs to be before or equal to the ending position. So if we have the starting position I and the end position J, then we have a constraint that I needs to be smaller or equal to J. That's by definition to have a substring, right? Because if you have a substring where J is smaller than I, then that's a different substring where J is actually the starting position and I is the ending position, okay? So that's just a clarification here for this constraint. And so now if we do the brute force is pretty simple. You just go through I from the range of n, and J, since it has to be smaller or equal to I, then you just do, it has to be bigger or equal to I, then you just start from I and go to the end. And all you care about is it has to start and end with the same position. And because of this loop, we already have this condition. And so if it starts and ends with that position, we just increment the count. So this is a little interpretation of the problem. But okay, but this is not optimal. It's open square, it won't pass. So how can we optimize it? Well, when you have a for loop where there is a brute force solution and you have 2 loops, the first thing you should think about is how can I remove these from being nested? How can I have this one separate and this one separate, and maybe do some processing here that will help out here? That's the way to think about one effective way to think about it. So let's try that. So what we can do is, well, we can just keep track of the start with of all the substring that start with C in a list, right? We can just keep track of the positions where they start from. So for example, in the case of this here, well, what we can do is just take this and say, which one starts with A? Well, definitely position 0. Sorry about this. Let's put this here. Let's put it here. So position definitely, if we do this one, it's going to be, the start with are going to be position 0, position 2. So 0, 1, 2, and 3, 4, right? Those are the starting position. Now, once we have these, what should we do? Well, we just need to do also the ending position and then see which one, and see the combination, which ones can construct a substring, right? So we need also end with. And so for this case, what would be the end with? Well, end with would be end with A, by the way. So what are the ones that end with A? Well, this one, 0 ends with A. This one ends with A. So now remember here, we did this one starts with A. This one starts with A, starts at position 2, and this one starts with A at position 4. Now for end with, we are ending position. This one ends at A. This one ends at this A, so 2. And then this one ends at this A, so 4. Okay, and now what we can do is just go through these and see how many we can get a substring. How do we determine if we get a substring? Well, we can just check this, the condition. And so let's do that. So we just first we create our start with and end with, and we go and for every now here just one single thing, we need to check that it's actually equal to C. Okay, because otherwise it doesn't start with that letter. And same thing here, we need to check if it actually ends with E, so S of J is equal to C. Now I chose here to do it backwards, just so that you can distinguish that this is end with. Okay, so we have start with, we have end with. And so now we can just check how many can give us a substring. So we can go through the start with positions, the end with positions, and if this one is smaller or equal to this one, that means we have a substring. And so we just increment our count and return it, okay? So this is, we were able to do this, but the problem is we still have that O(n) squared, just in a different shape, right? So for example, in a case like the second example where we could have just the same letter, this will end up being the same as O(n) squared. So how do we do that? How do we optimize? So we need to actually remove this for loop. How? Well, if you look here, what are we doing? We are just looking in this loop. We are looking for a J. We are looking for a J position. We are looking for an I position that is smallest or equal to J. So we want all the I positions. Right. So here we want all the I positions for end that are smaller or equal to J. We want all of them, and we want to count them and add them, right? And so what does that? So we want all I positions that are smaller or equal to J, if we just go through the J's. Now, how do you do this? Well, this is actually just, we are looking for, if we had the indexes of i's, let's say 0, 2, 4, and we have maybe J equal to 3, we are looking for the place where this position fits, because let's say since it fits here in this case, because 3 is smaller than 4, then we know we have 0 and 2 that are smaller than J. So we can just count how many, and there are 2. And so how do we do this? Well, we can just count the index where we need to place 3, which here is position 0, 1, 2. It's 2, and that's exactly how many elements we have. And so what this tells you is basically we need to binary search for J in I positions, and just add up to the count how many the position, because that position means how many i's we have to the left. So that means basically how many substrings we can get, right? And the other thing here is that what's helpful is start with, since we go in order here, start with is actually already sorted. So we don't even need to sort it, okay? And that's exactly what we are doing in this solution here. So end with, we actually don't need end with. So we get the start with positions, and then we go through the ending position, and for each one that is equal to C, we just find all the I positions before this J position, and those are the substrings that we can get, and we add those to count. Now, why are we adding the index? Because with this bisect, which is bisect right, it finds the position after the closest one, okay? Which means it's already the last I position where I is smaller or equal to J plus 1. And so that's what we add to count. And that's pretty much it. That's the solution we need to do. And this solution is actually more optimal. So if we just copy it here, let's put it here. If you take a look, this should be optimal because this is O of n, right? This is O of n, but we are doing this binary search, which is log n. So O of n log n. So it should pass O of n log n. So if we run this and then submit, it does pass, okay? So that's the clever idea here, is to go from brute force and keep iterating. You saw here we iterated twice to get to the solution we need. First, we tried to decouple the two loops, and then we tried to optimize the last loop that we had. Yeah, so that's pretty much it for this problem. I hope this was useful. Thanks for watching, and see you on the next one. Bye.